Welcome. Today we want to talk about conversion factors. So conversion factors, another important thing, usually shows up in the first chapter of a lot of chemistry books. You got to learn dimensional analysis is the method that we use a lot for unit conversions, and we're going to go through that and go over the basics. So one common conversion is converting between English and metric units. So a kilometer is, you can look this up on a table, a kilometer is equal to 0.621 miles. Not something you normally have to memorize. A kilogram is worth 2.20 pounds, unit of weight here. You could also turn this around. You could also say 1 mile is equal to 1.61 kilometers. Or you can say 1 pound is equal to 454 grams. So my proposal is that you don't really need both of these. You don't need to know 1 kilometer is 0.621 miles and 1 mile is equal to 1.61 kilometers. You only really need one of them. And that's usually what you see on tables is only one of these conversions, right? Because you can derive the other one. Just take, my proposal is 161 is equal to 1 over 0.621, and easily to convert those back and forth. So you don't really need both of them, but you might see either one on a table. Another possible conversion that you might want to do is between large and small units. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. 1 gallon is equal to 4 quarts. 1 foot is equal to 12 inches. And so these are the comparable units, but just giving you large and small versions of that. So these are the two most common cases that you'll run into, and we'll do some examples of each of these. So unit conversions, for example, let's do the distance one. How far in kilometers is the distance between Chicago to St. Paul? According to Google Maps, 402.1 miles. And they give you a nice little map there in case you wonder, where that is. Of course, Minneapolis is on the map and not St. Paul. And I've gone this road many times. I know every mile, I think, of the road between Chicago and St. Paul. So it's a good example for me. And I know that 1 kilometer is 0.621 miles. I got that from the table, my conversion table. So how do I convert the units? Well, I know I want my answer in kilometers, so I'm going to put 1 kilometer on top here. And my conversion for 1 kilometer is 0.621 miles. All right, so I start out like this because I know where I want to end up. If I just put 402.1 miles, start with that one, how do I know that's going to get me where I want to go? But here I know I want to end up with kilometers on the top in the numerator, so that's where I start. And it just so happens that in order for the miles to cancel out, I can put 402.1 up here, and then the miles will cancel out, and I'll get my response in kilometers. And I do the math here. Actually, the number I get when I punch in the calculator is 647,504,0258. But what do I got to think about? I have to think about significant figures, right? What is my significant figures here? I have 1, and I have 0.621, 3 significant figures, 402.1, 4 significant figures. Here we consider the 1 to be an exact number as far as significant figures goes, which means that it has an infinite number of significant figures, or it doesn't matter. It doesn't figure into the determining the significant figure. So you're taking 1 kilometer, it could be 1.000, it could be 1.0000. But we consider that to be an exact number. So the winner here is since we're doing multiplication, we have to find the term with the least number of significant figures, and the winner here is this one that has 3 sig figs, right? So the answer, according to the rules of using significant figures, is that we should have 3 significant figures in the answer. So we take 648. We have to round it up, and kilometers. Right, so this is basically dimensional analysis. You start out with a ratio, kilometers over miles, multiply it times miles. The miles will cancel out. I just love to slash those things with my red marker. It's really cool. And kilometers are left, and you know, the dimensional analysis allows me to keep track of units and takes us some of the guesswork out of, you know, which factor to write where. I'm pretty sure that I need to use 402.1 and 0.621, but should I multiply them? Should I divide them? This is dimensional analysis is a way to give me help on that, give me insight into that. How about weight or mass? So I want to know what the weight in kilograms of a person weighing 145 pounds. So where did they come up with this abbreviation for pounds anyway? LBS. I mean, what language is that in? Maybe you know, extraterrestrial beings from other planets, you know, use that kind of thing. I don't know. 145 pounds. I want to end up with kilograms, so I start out with kilograms on the top because I know that I want my answer in kilograms, so I'm going to put kilogram in the numerator, and a kilogram is 2.20 pounds. So this is called an equality, right? I have the same number on the top and the bottom, right? So I'm multiplying 145 pounds. I'm multiplying it times 1. So that's a term would be called an equality, or a conversion factor is another way of looking at it. So here again, pretty similar to the one we just previously did. The pounds will cancel out, and I'll be left with kilograms, which is what I want. And if I punch the number into my calculator, I get 65,909,0909. All right, so a long number, but not all the digits are significant. Here we have to look again. A kilogram, we said that's an example of an exact number because we're using that as part of a conversion factor. But the other part of the conversion factor does have a certain number of significant figures. It has 3 significant figures, and 145 also has 3 significant figures. So I'm gonna cut that off at 3 significant figures, and I don't have to round it up. So it's 65.9. What should I say? Kilogram. So you weigh less than kilograms. So maybe you want to go with that sometimes on your driver's license. Metric conversions. Conversions involving metric prefixes. Here we go. Okay, so this we actually did in a previous presentation, I seem to recall. But we can do this again because it's certainly a good practice for using dimensional analysis and conversions. Here, what is my conversion factor? I'm not given the conversion factor because this one I have to know. K, when I use it in kilometers, K is equal to 10 to the third. So this I know because I have to memorize that part of the table of metric prefixes. So 1 kilometer is equal to 10 to the third meters. So that's my equality. And I want my answer in kilometers, so I'm going to start out with kilometers on top and 10 to the third meters. And then I'm going to multiply this times 1.25 times 10 to the second meters. And in that way the meters are going to cancel out. I'm going to end up with kilometers, which is what I want. And here I don't have to put this in the calculator, believe it or not. I can just do that. I say the numerator, exponent in the numerator minus the exponent in the denominator. 10 to the minus 1 kilometers, right? Because meters get canceled out here. And significant figures, this conversion factor, the kilometers, 10 to the third meters, has as our exact numbers, so that doesn't really count as significant figures, as any number of significant figures, right? So that looks good, right? Conversion of meters to kilometers using equality as a conversion factor. Well, something you might want also to consider is percentages, ppm, and ppb. These are conversions that are also used in scientific calculations, so you should know how to handle these. So conversions involving ratios. So percentage is whatever ratio you're looking at times 100 is equal to a percentage of that ratio. So if I have 10 men in a class of 32 students, I would take 10 divided by 32 times 100, which is 31.25 percent. So these are counting numbers. 10 and 32 are counting numbers, so they have more than two significant figures, right? Because they have to be whole numbers. And then 100 is also an exact number. It's just a conversion factor. So we can go with four significant figures and 31.25% men. You could write the ratio here is males, men per students, right? Or 30%, 31.25% of students are men, right? And that's the so you can also do parts per million in the same way, is that parts per million is some ratio times 1 million equals parts per million. So let's say you have 2.25 times 10 to the minus fifth grams of mercury, Hg is mercury, in 1.00 gram of tuna, and you take that number and multiply it times 1 million, and that would be 2.25 times 10 to the 1 ppm. Right? So I'm taking that number, multiplying it times 1 million, which is an exact number. But this has 2.25 has three significant figures, 1.00 has three significant figures, so I can keep my answer in three significant figures and put it in scientific notation. And parts per billion also works. You take a ratio times a billion, and then you have the number in parts per million and parts per billion. And the important thing here is that these always describe ratios, right? So this is parts per million mercury in tuna, right? So if you have something like percent or ppm or ppb, there should be a ratio somewhere that you're describing, right? You should be able to come up with the ratio that you're talking about. So we'll do some examples here of dimensional analysis. A few examples. A method of setting up calculation that depends on aligning the units. I kind of described that already. Here's a little more involved problems using dimensional analysis. Car gets 32.5 miles per gallon. What is the mileage in kilometers per liter? And I have my conversion factors here. Kilometer, 0.621 miles. A gallon is 3.79 liters. So I know I want my answer in kilometers per liter, so I'm going to set up my equation that way. My two conversions are kilometers and 0.621 miles. And I want liters in the denominator, so I'm going to set up this one so I have liters in the denominator. I can use L for that. And now, how do I write 32.5 so that the units line up? I put 32.5 in the numerator, so miles per gallon. Right, and then that way the miles cancel out and gallons cancel out, and my answer is in kilometers per liter. I have to do the multiplication and division here. What number I get in my calculator is 3.808692225. So I have to be cognizant of significant figures. The ones here are considered to be exact, so we won't worry about that. 3 significant figures here, 3 significant figures here, 3 here. So the smallest number of significant figures for any factor is 3. So I can go 13.8. What are my units here? Kilometers per liter. Okay, or 1.38 times 10 to the first kilometers per liter in scientific notation. But here we did our 3 factors, right? This conversion dimensional analysis involving 3 factors. How many seconds are there in one day? You could count them, but that would take you all day to count them. But you can do the calculation and come up with the answer. And I need to know 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. So I want my answer in seconds. I'm going to start out with the conversion with seconds on the top, seconds per minute. And then to make minutes cancel out, I put 60 on the top here, minutes per hour. And then to make the hours cancel out, I do 24 hours in one day. All right, so now check my units here, see if I did that right. Minutes cancel out, and hours cancel out, and I have seconds per day, which is what I wanted. And I'm going to get, punch a number in the calculator, I get 86400, and this is seconds per day. Significant figures, well, these are all exact numbers because they're all counting numbers. I'm not talking about fractions of hours or fractions of minutes, fractions of seconds. They're all counting numbers, so they're all exact numbers. And so these are all 6 of these values are significant. So the best way to write that is to write it in scientific notation, and I can do 8.6400 times 10 to the 4th. Right, so there has to be a whole number of seconds per day, right? Because 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. All of these numbers, all of these figures should be significant. And that's the way I can write it. If I write it 86,400, then I'm kind of in doubt whether those 2 zeros are significant or not. Better to write it in scientific notation, then it's obvious that yes, all 5 of those figures are significant. One more example here. A 155-pound person has 16% body fat. How many kilograms of fat does the person have? Okay, kind of a gross question, but actually it came from the book, so I didn't make this up. So here we have the percentage, right? The percentage we're dealing with here. And the conversion factor is 1 kilogram is 2.2 pounds. And how did I come up with 16%? Well, I had a ratio of fat per body weight times 100 is equal to 16%. So if I want the fat per body weight, what number, how did I get that number? It's 16 divided by 100, right? multiply both sides of the equation by 100. So my conversion factor here, I'm setting out my conversion factor, is 16% over 100 is the ratio of fat per body weight. It's a number that describes the fat per body weight. Okay, so I want my answer in kilograms, so I use my kilogram on the numerator here. Then I know my answer, then I know I can set it up so my answer is in kilogram. And 2.2 pounds, and then 155 is pounds body weight. I can put BW there maybe, body weight. All right, so now the pounds are going to cancel out, and I have 16% of fat, which I want, right? I want kilogram fat per 100 body weight. All right, so that's fat per body weight is on this, this here is just rearranging that equation. So I got a number that describes what is the fat per body weight. Because this way, the pounds cancel out and body weight cancels out, and my answer is going to be in kilogram of fat, which is what I want. Kilogram fat. And let's see, do the punch the numbers in the calculator. I get 11.272727. And significant figures. Well, this one has 3. 1 kilogram, we consider that to be a exact number. 155 has 3 sig figs. 16 only has 2, right? And 100 is a factor, it's considered to be an exact number. So really we only have 2 significant figures, so 11 kilograms of fat for 155 pounds per person. So we converted pounds to kilos and then multiplied that times the amount of fat per body weight. And units cancel out, and so on that happy note, we'll finish the lesson.